Hello again, everybody. Today I'm wearing one of my Beale t-shirts, Beale being the high school that I taught at for the last 25 years of my career, H.B. Beale, named after the first principal. Beale actually had its own race car, and it competed in races at the local speedway. Race car is a very famous palindrome. If you look at the word, it's spelled the same forwards and backwards. There's all sorts of other neat palindromes as well. Do you know any? How about this one attributed to Napoleon? I'm sure he didn't say it, but it's about him. It goes like this. Able was I ere, or before, I saw Elba. Elba being the island where he was sent so that he couldn't cause any more trouble. Okay, last time, and I told you I would talk about this next time, we looked at the function y equals x squared, which we argued was equal to x plus a whole bunch of x's up to the last one where there's x of them all together. And by using that and taking the slope of this and this, I showed that 2 equals 1. Again, some of you still don't believe me. Well, if you don't believe me still, you've got to find fault with my proof. So why in the world does that proof not work? The slope or the derivative, once again, of x squared is 2x. That's certainly true from calculus. The slope of this one is 1 plus all the way up to the last x, which also gives 1. There's x of them, so that equals x. So if 2x equals x, 2 must equal 1. So what are your thoughts? Maybe you thought about this. Y equals x squared is a parabola, whereas that looks like a linear function. There's no powers of x. So maybe that's why this is not equal to this, because quadratic function and a linear function can't have the same derivative or the same slope. That has a constant slope if it's linear. That has a changing slope based on the value of x. But we showed that x plus all the way up to the last x, where there's x of them, is the same as x squared. So I don't think that argument holds any water. Well, what about this argument? For this to be true, I demonstrated it with 3 squared and 4 squared. Does it work for a decimal, like 3.7, 4.2? Because if it doesn't, then x only has discrete values, 1, 2, 3, 4. It can't be anything but in between. But for you to take the derivative of a function in calculus, the function must be continuous. Can't have any gaps in it. So that argument would show that 2 is not equal to 1. I hate to admit it. If you have any other ideas or comments, let me know. Maybe you found fault in some other way.